Well, welcome back. Tonight we're going to section 3.3 and 3.4. So again, a combo lesson. We're going to finish up 3.3 by condensing logs, which is going to be the opposite of what you practiced today in class. So we're going to be making these big long ones much shorter. And then we're going to show you how you're going to use this skill that you've learned by solving some logarithmic equations. Alright? Okay, so let's go back to your expanding rules from yesterday and make sure we reiterate them so that you're now ready to condense. Okay, yesterday, do you remember if you had log base b mn, to expand it you would write it as, remember multiplication you wrote as addition. So today I'm going to give you the expanded form. You're going to take me back to this form. Yesterday I also taught you that if you take the log of base b and you have m divided by n, then you're going to be able to write that as log b, and division is going to become a minus. Okay, and the last one was your power rule. If you had log raised to a power p, you could write that by bringing the p in front and multiplying it as coefficient. Okay, so again, today I'm going to start you with pink. You're going to work your way backwards. So same rules from yesterday, they're just going to look different. Alright, example 1. It's going to just say, write as a single log or logarithm. Be helpful if you guys could see it. I understand that. I need like a little zapper on my computer that as soon as you can't see it, it's like, and then I would know to move my paper up. Though that might be a bit painful. I bet I'd learn to look at the machine though if I had to do that. Oh well. Alright, let's go ahead and try this. So this time I'm going to start you out yucky and have you clean it up as much as possible. So the first thing I need to remind myself is that if it's expanded so that there's a plus, I can write that in shorthand notation by taking away both logs, writing it as just one. And now addition is really going to become multiplication. So I get 25 times 4 is 100. Now again, if you need to, remember if there's no base there, it's known to be base 10. So could I write 100 as 10 to some power? 100 is 10 squared, and now think about how all this is going to clean up, and my final answer is just going to be 2. So doesn't it look much better? We started with this whole gobbledygook, we ended with that. Alright, let's try another one. I'd like you to condense log 7x plus 6 minus log x. Now, just like yesterday, some of you guys are going to be great at condensing these right off the bat. Others of us are going to want to take some time. So the first thing I notice is that I've got this minus sign. So that's my sure sign that I'm going to go ahead and take and have a numerator and a denominator. I'm going to squeeze my log out in front because, again, I only want to have to write that log once. That's the benefit of condensing. Alrighty, so in the numerator I'm going to have 7x plus 6, and in the denominator I have x. But be careful, you're not done. What is this plus sign really looking like? No, I'm kidding, because I'm done. Sorry about that, I was just having a senior moment. Happens when you get almost 50. not over 50, at least not this year. Alright, let's try one more. I have 2 natural log x plus 1/3 natural log x plus 5. Go back to the one that I kind of stammered on. The reason you can't do anything goes back to the idea that it was in a parenthesis over here. It was part of a family, so I can't do anything further with it. If I had had log 7 plus log 6, I would have been able to do more. Alright, so, let's see. I got a lot going on here. I've got these coefficients, which I know are going to become exponents. So I'm going to take care of that first. So I'm going to write natural log of x, and this coefficient would become an exponent, x squared, plus the natural log, and this would become x plus 5 raised to the 1/3 power. Now I see this plus sign, and again I have the double log written, so I'm going to just write it one time, and I know that addition is really going to translate to multiplication. So I'm going to have x squared times x plus 5 to the 1/3 power. And really, instead of leaving it as 1/3 power, because that's just not something that we normally use, I'm going to take the cubed root of x plus 5. And that would be my final answer. Okay? We're going to practice a couple more. 2 log x minus 3 minus log x. Alright, the first thing I want you to do is take care of this coefficient. So what do you think you're going to do with it? It's going to become an exponent. So log x minus 3 squared minus log x. Alright, you see that this is safe inside its parentheses. However, I've got 2 logs, so I know I'm going to be able to do something else. So I'm going to bring out the log as 1, and a minus is going to become a division. So here is my numerator, there's my denominator, and I am finished. So are you feeling confident? Well, that's about to change. Let's look at this creature. 1/4 log bx minus 2 log b5 minus 10 log by. Whew! You guys think I was ever going to stop writing? Alright, first thing I wanted you to do is I want you to take care of all your coefficients. Okay, hope I gave you long enough. Log bx to the 1/4 power minus log b5 squared minus log by to the 10th. Okay, check yourself and make sure that you're good there. Okay, now, the next thing I'm going to do, and this is where it's going to get a little wacky for you, I'm going to go ahead and put parentheses around these two, because what I'm going to do is factor out that negative sign. Alright, so let's go ahead and do this. I have log b x to the 1/4 minus log b, I'm going to go ahead and write that as 25, minus log, I'm sorry, that would become a plus, log b of y to the 10th. Okay, now, think about it, this minus sign that I factored out is going to allow me to have my numerator and my denominator. The reason I went ahead and grouped them up here is if not, you'd end up with a really serious compound fraction. So it's easier if we just group them together and then factor it out. Alright, so we know we have a fraction because of the minus. In the numerator I have log b x to the 1/4. And in the denominator I have log b 25 plus log b y to the 10th. Now I'm going to go ahead and clean this all up. So the first thing I can do is write the log one time. Now instead of writing this as x to the 1/4 power, do you remember that I can write it as the 4th root of x? And in my denominator, you got one more thing to do. What is addition really going to symbolize? Multiplication. And you are finished. Okay, again, the more you practice, the better you get. That's why I had you do so many problems in class yesterday, and it's why we're going to do so many tomorrow in class. So, the second skill I want to teach you in this video is how to go ahead and apply everything that you've been using to solving an equation. Alright, so example 2, solve. I have log x plus log x minus 3 equals 1. So the first thing you're going to do to solve one of these equations is you're going to go ahead and condense. So, what does a plus sign really tell you? The plus sign says that what you're really doing is multiplying. Now I'm going to remind myself, because there is no base here, that I am working in base 10. And the first thing I'm going to do is now say, well, if I wrote this as an x, right, logs just bleh, don't like them. But can't I loop-de-loop to get rid of that and to get it back to something I'm a little more familiar with, which is an exponential? So do you agree that 10 to the 1st power is equal to x times x minus 3? Right? 10 to the 1st power is equal to that. Now I believe I can go ahead and distribute the x, and you get x squared minus 3x, and all of a sudden I have what looks like a quadratic equation, which you guys know how to solve. We're going to bring that 10 over, so I can set it equal to 0, and I'm going to hope that it will factor. If it won't factor, I'll do the quadratic formula. So let's see, does it factor? Things that multiply to give me 10, subtract to give me 3. I hope you picked 5 and 2. I need the 5 to be negative. I branch this off into its two roots, and do you agree that x is equal to negative 2 or x is equal to 5? Now, before you say, woohoo, I'm done, I want you to go back and remember the boundary of a log function. If you go back to what a log function looks like, do you remember that its domain was from 0 to infinity? So it never came over here. So you can't take the log of any negative power. So if you plug in negative 2, do you see that right there you're trying to take the log of a negative power? Therefore, we reject this root and we only accept 5. So my solution set is 5. Okay, it's all about the domain of the function. It cannot go past 0. Alright, you ready to try another one? Okay, where am I? Number 2. Log base 7 x minus 7 equals 2. Well, the good news is this one, I've got nothing to condense. It's as good as it can be. Again, because I can't do anything with this minus. Why not? because it's part of the family. It's protected in that house, those parentheses. But I am ready to loop-de-loop. So I can write 7 to the second power is equal to x minus 7. Alright, let's solve it. 49 equals x minus 7. Oh, good news, this isn't a quadratic, it's a basic linear function. Bring your 7 over, and you are done. If only they all could be that easy. Wouldn't life be awesome? Oh, but we are taking advanced math, so it can never stay pretty and easy. Let's try our last one for the day. Log base 4 x plus 2 minus log base 4 x minus 1 equals 1. So I'm going to go ahead and condense it so that we can use the loop-de-loop process. That's a very technical term, by the way, loop-de-loop. Alright, so the first thing I want you to do is I want you to try to condense this. So think to yourself, what does this minus mean? So I'm going to write my log base 4 one time. And I hope you remember that it was a minus sign is really going to translate to condensing to a division. Now that I have it with a single log, I'm ready to loop-de-loop. Reminds me of that song, you know, here we go, loop-de-loo. I won't sing anymore for you. That was it. That was your one moment of entertainment. So I have 4 to the first power is equal to x plus 2 over x minus 1. I think I should record all videos after 5 o'clock. I seem to be quite entertained then. Alright, I'm going to go ahead and clean this up. 4 is equal to x plus 2 over x minus 1. Now, I want to go ahead and clean this up. So, how do I get rid of this division? I'm going to multiply both sides by x minus 1. So, these are gone. I'm going to distribute my 4. 4x minus 4 equals x plus 2. Oh, good news, it is back to being a linear. I don't have to do any factoring. All you need to do is solve that for me. So I'm going to give you a second to try to do that. X minus 4 equals 2. 3x equals 6. So did you get that x was equal to 2? And we are done with this lesson. I will see you guys tomorrow. You have a fantastic evening. Don't forget your practice problems. And I'll talk to you tomorrow. Have a great one.